So factorizing with a common factor, it's tricky because it's kind of like division, and multiplying is easier than division. Expanding is multiplying, and factorizing is dividing. And what you're dividing by is the highest common factor, and I'll just abbreviate that HCF. And how you get this is probably the hardest part. So let me just kind of elaborate what this is a bit more, what the highest common factor of an expression is. Okay, so what the highest common factor is with these expressions is the biggest factor of the coefficients, of the numbers, and the lowest power of the common variable. I'm trying to use as algebraic words as possible here. Okay, so let's do this one first, looking at each term. And I've got three terms here. Biggest factor of the coefficients. So 16, 12, and 8 are the coefficients. And the biggest number, the biggest factor that goes into 16, 12, and 8, I think is 4. That's the biggest number that goes into all of those. And the lowest power of every common variable, well, a is a common variable with each term, and the lowest power that a has is a squared. And b is not a common variable, so that's not that's not part of the highest common factor. So right now, 4a squared is what's referred to as the highest common factor of each term of this expression. Now what I do is I do the opposite of expanding, and I divide each term by that 4a squared. Now instead of dividing, dividing's harder to do. So I just go like, well, 4 times what gives me that 16? Well, 4. A squared times what gives me that a squared? Well, 1. So I don't have to put that there. I don't have to put anything there. But I do have to put a b there, because 4 times 4 is 16, and a squared times that b gives me a squared b. And I just do that for each term. Right? 4 times what gives me that 12? 3. And how many more a's do I need to get a to the 7? Now remember, when we multiply exponents, we add them. So that's a to the 5th, because a squared times a to the 5th is a to the 7. 2 plus 5 is 7. That's how that shortcut works. And finally, that last term, 4 times what is 8? 2. And how many more a's do I need to get a cubed? 1. So right there, I've got my highest common factor is 4a squared, and that is my factorized expression. All right, let's look at another example, another expression of 3 terms. So biggest factor of 2, 4, and negative 6, they're all even. So the biggest factor is going to be 2 there. I'm working out the highest common factor. They all have an x. They all have an x, and the lowest power of that common variable is just x to the 1. I'll just leave that as x. That's it. That's my highest common factor right there. I'm done. And now what I do is divide each term by that 2x. And when I divide, I'll just say 2x times what gives me 2x squared? Well, I need one more x. Plus 2x times what gives me 4xy? Well, I need a 2. The x is already there, and I need one more y. And then I go to this term here. 2 times what gives me negative 6? Well, that's a negative 3. I have the x, and I'll need another z. So when you get your final answer, you better make sure that nothing in here has a common factor. So nothing inside the brackets a common factor like an x. And what you're doing when you factorize is you're breaking this expression down into its prime factors, just like prime factorization of numbers. So if I've got just some random number 24, I can break that down into its prime factors. 24 is 8 times 3, 8 is 4 times 2, and 4 is 2 times 2. So this is prime factorization of numbers. So I can say 24 equals 2 cubed times 3. And I'm doing this similar process here, breaking down an algebraic expression into its prime factors, just like I did here. One more example. Why don't we try this one on your own? I'll pause it, see if you can get the highest common factor, which, as a hint, let's say the highest common factor will be a negative, because it looks like the coefficients are negative 12 and negative 8. Okay, if that's what you got, well done. The only thing that's going to mess us up is the signs. Negative 4 times 3 is negative 12. Negative 4 times positive 2 is negative 8. So check to see if that's what you got. All right, so let's try these examples and see how you do. So I'm going to pause it and see if you get the same answer as I do.